Hello and welcome to today's IPHE presentation, part of a series to share information from various countries on their hydrogen and fuel cell activities. The International Partnership for Hydrogen in the Economy, or IPHE, was launched in 2003 to increase global intergovernmental cooperation and accelerate progress in hydrogen and fuel cell technologies. My name is Eric and I'm the host for today's three-part webinar. We're joined today by three representatives from CSIRO out of Australia, who will be giving an introduction to the organization, as well as an update on hydrogen R&D and hydrogen energy value chains in Australia. We'll be breaking up the webinar into three parts, and we encourage you to listen to them in order. So to get started today, I'd like to introduce Dr. Patrick Hartley, Research Director of the Oil, Gas, and Fuels Research Program, who will give us an overview of CSIRO. Thank you, Dr. Hartley.
Many thanks, Eric, and thanks for the opportunity to update you on Australia's hydrogen activities. So as you mentioned, there are three speakers. I'm going to give a bit of an overview of the strategic activities around what the future looks like for Australia's hydrogen industry, and then we'll drill down with the other speakers, David and Daniel, on some of the more R&D and demonstration activities. So I'll jump into my slide set now. Just a little bit of an introduction to CSIRO for those that may not be aware of the organisation. CSIRO is Australia's national science agency. It is an agency that looks after all aspects of R&D of importance to Australia, obviously. Established in 1926, around about 5,500 people, geographically very diverse across Australia. We have locations all across the country. And we have about $1 billion Australian budget, and we have a lot of R&D, which is both focused on innovation and fundamental underpinning science for the country. Highly educated, obviously, as a science organisation, so highly trained workforce with many doctorates and masters qualified staff. And we work extensively with all of the universities really across Australia. So we don't grant our own degrees, but we collaborate extensively with Australia's university sector to co-supervise students and work on collaborative projects with them. Our activities really span three main areas. We look at impact science, so we focus very much on the science that matters to Australia, that will solve challenges facing Australia. We manage a number of national facilities and collections on behalf of the Australian government and Australian people. And we also have a services arm, which is really about assisting our industries to develop and grow nationally and internationally. And our R&D is organised. I'll just touch on this very briefly. You can see that in the blue section there, our R&D is organised in business units, which really address all of the different important sectors for Australia, right from agriculture all the way through to food and nutrition, and energy, of course, which is where we three speakers work. In terms of our energy R&D, we are organised across the energy value chain, and we look at both resources R&D, so resource exploration and trying to improve productivity of our resources, as well as reducing emissions from them as they are produced and used. We do a lot of work on renewable energy in the low emissions technologies program, and on the more downstream aspects, if you will, looking at how Australia's power system and energy system is developing as we go through our energy transition, which of course many countries around the world are doing, and hydrogen is a big part of that. So with that, I will jump into the discussion of our National Hydrogen Roadmap, which we delivered in August last year, and was a big piece of work, fundamentally looking at what the future looks like for Australia in the world of hydrogen. So let's first of all look at why hydrogen matters for Australia, and many of these things are similar all over the world, but obviously hydrogen can be used to decarbonise very many different energy and feedstock value chains, from simple industrial uses right through to all aspects of the energy system. Perhaps the important differentiator for Australia in many ways is the opportunity for export. We have quite a low population, and as I'll show you in a moment, some extensive energy resources that can be used to produce extensive amounts of hydrogen. And so the export opportunity for Australia is one that's particularly getting people's interest. So just to look at that now, you can see that this rather complicated graphic looks at all of the different types of energy that Australia has in abundance, and you can see we have extensive fossil fuel resources, both coal and oil and gas, in the different parts of Australia. And in terms of our renewable energy footprint, we have a tremendous solar footprint, particularly in the centre and west of Australia, and tidal resources as we push down into the Southern Ocean, and all other sorts of, well, potentially geothermal energy. Geothermal energy is an opportunity for Australia, which hasn't really been developed extensively yet, but the resources are well known. So these are all resources, of course, that can be used for producing hydrogen, which is why this is of particular interest to Australia. So why now? Why is hydrogen in Australia really being looked at, and around the world? Why is it being looked at in particular detail at the moment? Well, we see from our studies and discussions in developing the roadmap that there are a few simple reasons. The first is that the technologies which underpin hydrogen industries are reaching a level of maturity that allows them to be commercial and to develop commercially much more than previously. The second is that the cost of renewable energy in particular have really fallen dramatically in recent years, which makes the production of hydrogen from these resources a real opportunity. Particularly for the export opportunity, we're seeing the development of overseas markets. We're seeing markets emerge, particularly countries like Japan, who in their national strategies are seeing import of low emissions hydrogen as being a key opportunity to transition their economies. And so all of these, we think, lead to the simple observation that really the hydrogen industry narrative has shifted from one of R&D and technology development really to market activation. And it's really enabling that market activation which our roadmap tries to address. So there's quite a lot of work done in 2018 around this area. I'm here talking about the National Hydrogen Roadmap from CSIRO. This forms one of three major pieces of work which were delivered by various different agencies in Australia looking at this hydrogen opportunity. The middle document there was a document that was prepared for the Australian government by the Chief Scientist of Australia, and really was intended to brief them on the opportunity. Our document was more of a let's say quantitative and analytical, and there was a third piece of work which really looked at that export opportunity, which I mentioned as being very important to Australia, and that was delivered sponsored by the Australian Renewable Energy Agency, which is a part of our federal government as well. So the National Hydrogen Roadmap, the primary objective of that was really to assess the opportunity for Australia, and really to help and inform and coordinate both industry investment and government policy development in this area. It also had a secondary objective, which was really bringing together a broad stakeholder group. We have a large number of companies emerging in the hydrogen sector in Australia, and we sensed that there was a bit of a need to bring that group together and really develop a shared view of the future of the hydrogen industry for Australia. In terms of what we looked at all aspects of the energy system, right through from electricity generation, obviously, use in direct combustion, transports and fuel cell vehicles, the export opportunity, which I've touched on previously, and the use of hydrogen in our industries as well. We really looked across the value chain, so we assessed different elements of the value chain in order to develop this picture of hydrogen industry development in Australia. So we looked at production, and we confined our studies really to technologically ready technologies. So on the production side, we looked at thermochemical processes and electrolysis, which was of course developing rapidly as a way of using renewable energy in particular to generate hydrogen. We looked at the different aspects of storage, be they compression, be they liquefaction, be they chemical storage. We looked at transport, And we looked at the utilization in heat, in stationary electricity, industrial feedstocks and transport, as I mentioned. So really trying to build an understanding of the value chains in Australia. The methodology that we used was to base case model these mature technologies, to look in that modeling to really identify the material drivers of cost, with a view to understanding where costs could be brought down, where were the lowest hanging fruit in terms of reducing the costs of hydrogen value chains across hydrogen value chains. And we looked at investment priorities, be they commercial and technical, be they policy, regulatory, in terms of the research, development, and demonstration, and issues of social license to operate, which have been really emerging in Australia and many countries around the world in recent years in the energy sector, of course. And then in doing that, having identified the material cost drivers, we applied what we felt were realistic improvements in those costs to develop a best case scenario by 2030. So we take the base case, which is where we saw the world now, and then we developed a trajectory, if you will, of best case costs for hydrogen production by 2030. Some of those best case models, some of those key material cost drivers are shown here, particularly for just for one example. There are many others in the roadmap, but for PEM electrolysis, we could see that we identified some key material cost drivers from the tornado charts that we used in the roadmap. So things like economies of scale through plant size, increases of efficiency, capital cost, input electricity cost, etc. And so these are the things that we really then started to move around to develop the best case scenarios. And so things like a 10 times increase in plant size, and a change in renewable energy prices, to see how that really affected the cost of hydrogen. And so this is what the base curve looks like for that trajectory of hydrogen production. And so we looked at, and these are Australian dollar prices. So we see that starting around about now, we felt that the base case scenario had around about $5.30 a kilo. And that the best case we could achieve by the mid-20s and through to 2030 was around about $2.50 based on those optimizing those material cost drivers in the roadmap. And so that's our starting point for our analysis, really. And the next stage of the analysis is really to understand what costs different applications for hydrogen could tolerate within that overall framework. And so in doing that, we identified three zones in our cost curves, if you will, which is costs that are costs for hydrogen to displace existing technologies in this green zone at the top of this curve are above what the cost is now, so they're essentially ready to go in terms of a cost basis. Of course, there may well be other barriers, and I'll touch on those in a moment. In this zone, in this central zone, things are cost challenged now. The applications that can bear the prices are cost challenged now, but they are projected to become cost competitive around about 2025, 2030. And applications in this lower zone have cost and other barriers which they need to and potentially other barriers which they need to overcome by 2030 if they're to be economically competitive with the existing technologies. And so in terms of market applications, again, we looked at the price point at which hydrogen could become competitive based on those analyses we've done previously. That's with the current technologies and feedstock. So, for instance, if you're talking about hydrogen in heating, obviously the competing technology is natural gas. So, at what point is hydrogen able to displace natural gas in heating? And similar approaches for the different applications. So, noting that the analysis doesn't include a lot of the following factors, so things like the supply chain localizations, how we can actually improve economics through industrialization and automation. The great I guess stimulus here would be the development of an export industry, which probably changes things quite significantly. We didn't factor in environmental cost and carbon pricing risk. And we didn't, given the resources, we didn't really look at energy supply risk within the studies. Very important to observe that the competitiveness cost curve, which forms the core of the roadmap, is not the only driver. So things like stakeholder interest in decarbonisation, for instance, are all significant factors that can shift the development of the industry. So here we are again with those three zones, and now I'll start presenting you with the analysis of the different application areas, the different opportunities for hydrogen. So in this green zone at the top of the curve, we identified that the costs for hydrogen were essentially already there, and that so for vehicles, particularly passenger vehicles and trucks where you're looking at displacement of gasoline or diesel, that hydrogen was essentially competitive on a cost basis with those technologies. However, very important to observe, infrastructure is a key barrier to the development of an industry in those areas, simply because we don't have a great deal of hydrogen refueling infrastructure, for instance, in this country at the moment. And so that's the key focus for developing that sector of the industry. As we move down, we see the supply cost barriers starting to emerge now, which will be soluble, we think, within the next 10 years. So in areas such as remote area power systems, which is a very big opportunity for Australia, since we have quite a extensive area of Australia which is not covered by grid, and where activities such as mining are looking for remote area systems that they can use to develop both their communities and their industrial sites. So remote area power systems is something we see as an opportunity in the near term for hydrogen in Australia. And moving down that curve, you can see industrial feedstocks and export as being opportunities that come online as those costs for hydrogen production come down. On the lower end of the curve, where the competition is very intense in a sense from existing technologies, we're looking at things like grid firming services and development of fuels. Again, you're looking in these areas, you're really looking at displacing cheap fossil fuels, so they're more challenging at this stage on a purely economic basis. And similarly, residential heat. So the use of hydrogen in residential heat has both supply cost barriers and infrastructure barriers, since the infrastructure for delivering hydrogen is not quite ready yet. So that was really the core of the roadmap. So I'll just summarise those observations in some key messages from the roadmap. As I mentioned, market activation is the key priority for developing the industry in Australia. That the barriers to market activation stem from both lack of infrastructure and the cost of hydrogen supply. That many applications become certainly achievable and favourable for hydrogen in the run-up to 2025, 2030. And that really this export industry opportunity represents a game changer for Australia and for hydrogen in Australia, due to largely to the increases in scale that will bring. And of course, that in order to make this all happen, an appropriate policy framework to develop those value chains, those market pools for hydrogen will be required, and that the investment in the value chain infrastructure will follow. Just a very quick note on some of the existing activities that are here in Australia, which might be of interest. And this slide's probably a little bit out of date now. It's really current as of about September last year. So all across Australia, we have a number of demonstration projects kicking off or being proposed in different areas, be they around export, be they around renewable energy production and introduction into the gas grid, be they for industrial applications, and so on, and vehicle trials, etc. So quite a diverse set of opportunities that are being pursued across Australia, and we're looking forward to seeing those develop in the next few years. In terms of the roadmap, how it was put together, we had that slide I'm afraid you can't read very clearly, but we had a large number of stakeholders that were involved in the discussions and the consultations around our findings and developing our understanding. We were very grateful to our project sponsors, some of which are at the very big end of town, and also smaller SMEs looking in new hydrogen technologies. And of course, most importantly, the project team that really worked on this project from CSIRO. So Many thanks to all of them who did both the techno-economics and the stakeholder engagements, etc., around the roadmap. The website, the report is downloadable at that link at the bottom of this page, and I think I'll leave it there.
Thanks again for the informative presentation, Dr. Hartley. That concludes part one. Be sure to check out part two of Australia's update for IPHE to learn about their hydrogen R&D efforts in the next recording. And if you have any other questions, please visit the IPHE website at iphe.net. Thanks.